Today, we're looking at a wild invention that's basically a flight simulator for eye surgeons.
So how do you practice something as delicate as eye surgery? Turns out, it's a huge problem.
For ages, surgeons have trained on models that don't move. But a real eye? It's never still.
Those old models are just stuck. A real eye moves, resists, and the eyelids are part of the challenge.
Basically, these old trainers just don't capture the real dynamics of surgery, not even close.
But now, a new patent is changing the game. Think of it as that flight simulator for the eye.
It's a system built to copy the exact feel and movement of a living human eye. So cool.
So what makes this thing so revolutionary? Well, it boils down to 4 key advantages. Let's dive in.
First up, it moves. A gimbal system, just like on a camera drone, lets the eye move naturally.
That means the eyeball can rotate a full 30 degrees up, down, and side to side, just like real life.
And it's not just movement. It has features like resistance bands to simulate actual muscle pull.
And you can dial in that resistance to the exact scientifically accurate range. That's a huge deal for feedback.
Second big thing, a super precise magnetic mount holds the practice eye perfectly in place. How precise? We're talking within 0.2 millimeters. That's a massive improvement over the old ways.
Third, the eyelids are actually functional. They work with the real surgical tools used to hold eyes open.
And the level of detail here is just incredible. They've mimicked the eye's anatomy right down to the liners. And fourth, it's not just a fancy eye holder. It's a whole platform for all kinds of practice.
You can adjust everything. Eyelid openings, fluid systems, you name it. It's incredibly versatile.
Okay, so what's the big picture here? Well, it's all about making surgery safer for everyone.
For hospitals and schools, this means way better training, smarter use of resources, and more efficient learning.
And here's the ultimate goal. Move that risky learning curve from the OR into the lab.
The impact? Less risk in the operating room, better skill checks, and most importantly, it's safer for patients.
And get this, it was invented by a surgeon. He built it to solve the exact problems he faced.
This tech really bridges that huge gap between simple plastic models and actual live surgery.
So could this tech make that risky operating room learning curve a thing of the past? It's really looking that way.